absolutely streaming today. It was nice. He's nice. The score not open, nothing open. Nice. Will the chat keep in the VOD? We activated that. Alright. This model that I call it net, so net dot train description equals training. How did I write that last time? It's model, but model is actually my net, right? This is a I think no, I'm just trying to replicate that for any type of input this time. And that dot eval description equals testing, evaluating. I did test, right? I called it the validating. Okay. Validating. Now for data and track description is equals description, and we're gonna train through the data loader. Nice. But now I think it's not data, right? Yeah, I have it right here. It's inputs and labels, because now I'm opening it first. Inputs, labels. Called device equals storage dot device. Oh my god. And a string saying CUDA. I think that's how you write that. I usually don't remember. Well, let's see. Device is storage dot device. Yeah, storage dot device. I will read the chat if something comes in. Actually, I'll drag it there so I can actually see stuff. So, what was that? Auto duplicate whole line in Vim? Yeah, good question. I still don't know how to do that. I still have to press YY, and then I will just have to delete it right after. YY and P, yeah. We'll delete P. We'll put a grabbed by either and previous. Yeah, P is. This line is stored in the line. I don't know. Maybe I'll find out. Who knows? By the way, my mic is working, right? Yeah, my mic is working. And I'm using the right microphone. Okay. Just to make sure about that. So now instead of coming that from data, now we do inputs equals inputs to device. How do we say that? Yeah, inputs to device. Now you get all the images from the train set on training, every image actually, into the GPU. So now labels to device. Since we're using CUDA, we're using the GPU. Now zero the parameter gradients is pretty important to do. And now I'm gonna rewrite the function. Alright. Now we come with these and done. These print. Also, I'll try to prettify it later, but for now, let's keep it simple. Now optimize zero grad. on. Now I just learned about these today. This is a pretty cool function about torch. Like before, I would do it with torch, no grad. Right? This is what I would do. And then everything I write right here will not use auto grad. Like auto gradless. It will not calculate any gradient. But you have something quite interesting, which is this set grade enabled, which is a function that takes a boolean, true or false, and you can pretty much write everything here, and it will do with grad. We will do with the grads. You will use autograd if it's yes, and it will not use autograd if it's false. So if phase equals string, it means this statement will be true. So we will use grads, but if it will be unvalidated, it won't be used. So this is some really cool trick. Here output equals model, which is, I hate to do that, but I shouldn't call my net. It makes more sense when you call it model, so I have to also say model.train, model.evolve, but everything is model-wise. Model. Alright. Now output equals model.inputs. So now you're pretty much passing it. It's the model, by the way, is that one here. So nothing fancy. It's just a. I think I even copied that from PyTorch.org. PyTorch.org. It's a simple net. It's not the smallest one, but it's their example. Right? Oh no. Oh yeah, right here. So this is the model. Model.inputs will pass it. It will be kind of a forward pass here. So now we have to calculate the outputs from it, which will be. Wait a minute. SP model apply. It returns X. So I don't think. Usually you return probabilities. Like the model right here. What was it returning? This was ResNet 18, okay. But I don't think I can put like, or outputs will be model inputs, but model only returns X. I think, I'm not sure, but I think that this syntax is wrong. Unless something really weird is going on, but I think this is not going to happen because my model doesn't return both of them. I have some models that did that. Let's see what I did to return both. The first information is useless, by the way, but I'm just curious. Where did I implement something smart that way? I do have some code here now. There's the notebooks, ML, IPy, and beta might do the job. Fuck off. Oh no, it's gonna open my work. It's gonna open my work. This is not okay. I can't open this type of information. Yeah. Machine learning, ML, IPy, and beta. So this should show the. So I can actually see. Oh, the model was actually returning X stuff. I don't know. Why would my class return 2 parameters? Really weird. Okay. Let's do it that way. If we got a bad problem, let's just do prets. But I think it usually returns probabilities and softmax probabilities. That's why it has 2 things. Well, let's check it. This should be outputs, right? No, it's torch max of output. Torch.max outputs, and we want only one value. So. Oh, I see that. This comes from torchmax. I think torchmax actually returned 2 values, right? Input tensor returns the maximum value of all elements in the input tensor, so it returns only 1 value, right? So if you do torch rand, no, it returns only a single tensor. What is that one? A1. Output tuple, result of two output tensors, max indices. So if you do A, it's a random from a matrix, and you do torch dot max, you will return types max L. I don't know. I think this is from torch. Okay. So let's keep copying and understanding. Later on we'll do with cifar100 and build better models. Bro, this feels like Wildwoods from Mario Kart 8? I don't remember that. Okay. I'm curious now. What is that one? It returns the highest vector? Yes, is it? The result tuple of two input tensors. Huh. Curious. But I didn't get it. Okay. Why am I with the model on top? Oh my god, what have I done? 0 primary gradients W. Let's just close this guy here. So now we have to calculate the loss. Will be, if I have set criterion here on top, we should have criterion, yeah. So criterion, and we take breadths, I guess? No, outputs and labels. Makes a lot of sense. So we're gonna calculate the loss using cross entropy loss, which I don't really know what it does, but I will know in the future. So we're gonna give it outputs and the label. So it has right here calculates loss. I mean, I don't have to comment these lines, right? But it's pretty simple. It calculates loss, and it picks the right labels and to calculate based on the output predicted. Yeah, that's what it does. So now that we calculate the loss, I mean it's right here, but hold on a sec. Alright, let's get back. So now we do the... So this was pretty much the forward step, right? Until here it's forward step. So forward step. Now we're about to do the backward. which means now we calculate gradients using AutoGrad. We have one viewer. I think this one viewer is myself actually. It's really weird. I don't know if YouTube count myself. So now the backward step, which is pretty much if phase equals strain. Pretty much we don't want to calculate the losses, because we only do that we only do that when in training, because well, we don't calculate validating, we're just validating. So loss of backward and optimizer dot step, which is the, oh my god, just realized something here. No, that's right, which is pretty much the SGD. I'll comment that, like, some people don't know the meaning of it, so stochastic, I think it's how you say it. Stochastic. It's a little bit more fancy. It's stochastic gradient descent SGD. Alright. So, lost the backward optimizer dot step, which I wrote wrongly again. Optimizer dot step. And now finally the statistics. I mean, you can see I'm copying from here, right? This is an old project using the ResNets when I started to get a clue on PyTorch. So pretty much, I remember I copied that code from a lot of different places, and it turned out that it worked with pretty cool set of data loaders, where you would put the entire data loader of train and validating inside of a single variable, and it was pretty cool because it was optimized enough on its for loop, because it does the same. So it's pretty clean code and I liked it a lot, so I'm trying to copy that. So running loss is the running loss times inputs size 0. I don't really know what that means, but I think this is batch size, right? Like inputs dot size. Inputs dot size torch. I'm almost sure this is batch size, just because when you do transpose on inference, you usually have to add this extra dimension on the start that will be 1 on inference, that it's the batch size. So I'm not sure if size 0 means it's the first number and on the dimensions or what. This is what I don't know. Oh my god, no, it's okay. I'm not sure. I want to. I don't know. I mean, it's inputs. Input is a tensor, right? With all images. So what we do with that is, I'm pretty sure this is times batch size, but I can't confirm. Oh my god. But I think it's batch size, so it makes a lot of sense. It's the running loss times the batch size. So if you're doing that in batches of 8, you have a loss for 8, for a batch of 8. So you have to multiply it by 8, I think. I will print data later and see what it is. This is badly indented. Okay, so running loss. Is that? Now we do running corrects, which is pretty plus equal torch.sum of preds equal labels data. So torch.sum, I mean, I know everything is quite itself, right? It's self-explainable, but I want to know. Returns the sum of all elements in the input tensor. Okay, so what it does is that it takes all preds, which... What is preds? Oh, here. Preds are is the tensor with my predictions. So when I compare the predictions with the labels.data, which is another tensor, so I'm not sure how it does that, but it will pick up its sum basically when these statements are true. So I think this will run the Preds tensor, and Preds tensor is the same size as the labels.data. It will compare, and every time it's equal, it's sum, you know. But here I actually think the Preds only will hold the batch size tensor. So I think I set the batch size for 4, so Preds will be a tensor of 4 predictions. I'm not sure, so I think Preds 4, it's batch 4, it's a batch of 4 inputs, and we compare sum of statements that matches the labels data. The point is, I don't know why labels.data would follow the tensor, but it's storage.sum. It's a good way to do that, but yeah. Alright, running corrects. I don't have a I don't know how to pronounce that actually. I'll learn it now. Scheduler. Scheduler.
Scheduler.
Scheduler, yeah. That's how we say that. I don't have a scheduler because this is a simple net, so I won't do the scheduler.step. And what I will do is the epoch loss equals running loss divided by dataset sizes face. So if you don't really understand that, basically I wrote both datasets in a single variable, which is the data loaders, and we calculated dataset size for each of them, and we have a list. Actually, it's a dictionary with train and val, and there is numpy arrays, right? Or torch, whatever. So it holds the LAN of image datasets. So it takes all the images in train, which is here it's pretty simple to know because it's cifar100. But for your datasets, you likely don't have to know. So there's a variable here that holds the size. So it will be pretty much the loss will be the running loss, which we calculate from the entire process. So here I think this is not batch size anymore, but you calculate it from the current running loss divided by the entire dataset, which I think I actually wrote that. Hold on a sec. I mean, I was watching the Andre Confarthi classes, and I think this is one of the things I take note of. I think I took note of it, but I'm not pretty sure. But I think I did. So the log, yeah, I learned the multinomial logistic regression or softmax classifier. So big cat is in the example cat is the right answer. So for that input, does li loss for that input loss is 0.8. Yeah. No, I didn't take note, but I do remember I saw that in class. And you would calculate that for the entire data loader, so your running loss is actually the entire loss for every batch, which then I think this is wrong actually. I think this should be divided, but I don't have any reason to do so. The code right here works, so I'm probably wrong. So we're gonna divide it by the dataset size and the epoch accuracy, of course, is the running correct that I've just calculated. Dot double? I don't really know what these does. Python dot double. Does it cast it to double? I mean, usually you do stuff like int, and it has this property, or float, or, you know, string, byte, or bin, right? You cast things like that, but here you do dot double. Really weird. Sorry about that, I'm just talking in WhatsApp since no one is watching. So. Alright. So let's say double. Is it like a pure cast to double? Dot double. Alright. Int or integer, float, or double. I don't remember the difference of float and double. I know it's the precision of floating points, but I don't remember how different they are. Double precision floating values are double precisions. What? Where is double? Alright. I still don't know. Cast to double Python. There you go, use float, which behaves like and has the same precision as a C, C++, or Java double. Python floats are C doubles. I didn't know that. I thought float points were float points, but I don't remember how big is a float in C. Float C size. Is it 16 or 32? A float is a 4 byte, so it makes sense. 4-byte precision. So you can, I don't know. The float point is 16 or 32. I don't know. But what is that double? Correct that double. I mean, I will say this is a double. Maybe this is a true double because floats act like double. And doubles are smaller than floats. Alright. I'm not sure, but float and Python are C doubles. Python float precision. Double precision gives numbers have 53 bits, 16 digits. While precision and regular floats have 24 bits. So doubles are, in fact, really much bigger than, I don't know. Float versus double. Which one's the biggest? Huge difference, as the name implies, a double has twice the precision of float. In general, double has 15 decimal digits of precision, while float has 7. Here's how the number of digits are calculated. Double has 52 mantissa bits plus 1 hidden bit, so log of 2 to the first 3 divided by log of 10, so it gives the... Sometimes when double isn't accurate enough, hence we have something called long double. Yeah, I think it's casted to double because double is the biggest shit ever. I don't think you have long doubles, but you might have it to double because you might have it. So I don't know if it's truly needed, but since it's precision, you usually want to have the precision as high as possible. Usually you want precision as high as possible, right? So that's why it calculates it as double, I guess. The double is real double, I guess. So let's do that double. And again, we have to divide dataset, size, and the current phase because, well, dataset sizes are different for training and validating. Now it might be done. It might be done. I think now I just have to copy the trash thing and build them. I think I already imported copy. No? How do I find things in VI? Oh, I think it's slash copy, like that, yeah. Okay, I have copy there. I imported it, so I can actually do so. If phase equals validating and yep, fuck off. And epoch accuracy is higher than the global one, which is the best accuracy. We say that the best accuracy is now the best accuracy is the epoch accuracy, and we copy the entire dictionary that holds the model. So model weights equals copy, copy, and we take the model, that's the dict. And it might be done. Actually, this should be everything. And running loss goes 0. I don't think this is right now, but I think running loss should be 0 at some point. I just don't know where. Definitely not here. I think I did that on top, right? Haven't I did that on top? No, but I think here is where I should do 0 the components, right? So running loss is a float, so 0.0, and the running corrects for every time you're running these things. Should be 0 as an integer, and just delete that. Alright. Of course we have to print statistics. So yep. Print f-strings. F-strings are great. I love f-strings. I did hate to write things in the other methods. So we're gonna write that loss loss equals loss with 4 points of precision. No, you write on side it. Point to f. But for f, for high precision. Okay. And space, accuracy. Should have a space here as well. Let's make it clean. Should be as well as epoch ACC? I think it's like that, yeah? Yeah. Point 4F. Is it? I should say which epoch is it as well, I guess. Hi man. How are you doing? Long time. Actually, you called me yesterday, but I was on dinner, so I didn't answer fast enough. Sorry. This is not here, so here we should run epoch. Is it epoch? We calculate no, we calculate for phases. So here should be a string containing it, so it should be phase itself. So if you train, and then the losses, right? Do you know fast inverse? Fast inverse is square root. I do know. I don't know how to write. I don't know what it is, and no, I don't know how to do it. I saw the code once, but I didn't understand it actually. But I know it was used in Quake, I guess. It's a method to calculate the fastest square roots pretty fast, and I think you use that for calculating. I do know you use that for some vector calculation. I don't really remember where, but I think you do that for when light comes in objects, and you usually use the light or something like that to check if something is in a camp of vision. Is it fog? How do you say that? Field of view, right? Fog, yeah. You use that to calculate if something has to be rendered, I guess. So, since it needs to be calculated a lot of times per cycle, they had to optimize it a lot, right? So it's a really weird code, but somehow it works. Running loss, phase model, I think everything is right. Phase. Hold on. we should do time.time. We have to calculate how much time it does. So start time, and here we're gonna do and time.time and f string again. Okay, f time minus end, actually end minus start, and we do that like these, and it gives seconds, I guess. So time elapsed so far. No, time elapsed. So stop. Okay. Finished training. But I don't really remember. Fast square roots. Fast inverse square root. Use. Is used in calculating a normalized vector. Programs can use normalized vector to determine angles of incidence and reflection. Yeah, I was sure. I was right. That's why I use. I just saw that actually in my linear algebra class, that you had to calculate these things, and I thought you would need to calculate the inverse square root. And then I finally clicked in my mind, like, oh, that's why there's the fast inverse square root. Yeah, that's why it's used. But no, I don't understand a shit about that code. It's really weird. Really weird code. Like, what the hell? Like, there's this float. I mean, it might mean something in memory, but I have no idea from where that fucking shit comes. You pick up I, where I is the pointer. You cast. So okay, let me try to understand that. You pick up a float number, and then you do long I, float x2 and y. Okay, it's just declaring variables, and 3/2 is 1.5 as float. Okay, so now x2, it's a number times 0.5f, which should be half. Y is the number, I is a pointer to... Actually, you go into I address, you cast it into a long pointer, and you dereference the pointer. Okay, so now you have a long valley from what you had from Y, where I was long, so I don't really understand. No, I was long, Y was not. Y was float. Why did you declare as float and did that? I have no idea, but feels like something goes in memory on really high precision here. And then I is this address minus I with a 1-bit shift for right. Then you dereference the pointer and cast it back for float as I. You cast the pointer, which was a long variable, you go into the address, you cast it to a float pointer and dereference it. And then you iterate it to get more precise, because this is not the precise fastest square root, right? Inverse square root. You can do like more iterations if it needs to be really precise, but yeah. Again, I have no idea where these values come from. It's really weird. But it feels really smart. Do you understand that? If you understand it, I would love to know what is going on there. Especially that float valley here. This absolutely means a valley in the memory, so I have no idea. What does it mean, actually? Let me take a look on that. Wait. Oh, 0x is just to mean, oh my god. It's 5f, 37, 59, df. So this is a really weird precision here in memory. The position of... I was wondering if the bits meant something, but they're truly a 32-bit sequence. And then you do it minus I to the shift. I have no idea what that fucking shit means. Really weird. Let's keep it. I think now it works. So we'll do /kill, /w kill, and Python. Let me do it clear first. Python train.py. Invalid syntax, of course, on line 43. What is wrong there? Wait, what? Where's the wrong syntax? Am I... What? What's going on there? What the hell? Or was it... Folks 25, poke, and range, folks, the poke. Bro, what? What? Maybe it's before. But why on earth would it tell me the errors here? Did I write an F string wrongly? What? What is going on? I don't see it. Is it wrong? Is my print wrongly? Did I wrote it wrongly? Poke and poke. This is a variable, alright? I mean, I will comment. See if it gives me... Okay, this is a problem, though. This is a problem. But the other one, I don't think it was. How was it called? Okay, I go there. No problem. I don't understand. Why is it wrong? That's really weird. What the hell? Do I need to say this is an expression? No fucking way. No, it's wrong again. That's a really weird error. Is that a problem with my app strings, maybe? It's again saying this is wrong. Python version. Is that how you call it there? Python 3. I'm running Trio F5. This has F strings. What the hell? I don't understand it at all. I'll create a new one here. Python tree train.py. Name data loader is not defined. What? getting so much weird errors. But I think I didn't say it was like that. Here's data loaders. What do you mean? Data loaders. I think I wrote that without the S. Okay. Oh my god, I closed the Tmux. No worries. Too many valleys. Yeah, that's what I thought. This is no surprise. But yeah, I think that this is a Tmux problem with F strings. Really weird. Wait, too many valleys turned back? Input labels and data loaders, you don't have so? What? Data loaders is a two-dimensional. That's weird. Oh, is in data loader phase. Of course, data loaders is the dictionary with tray and val. So, face. And I'll keep the preds with that because I think this is torch max shit. It gives like the max value here and the other tensors that are not the highest on that shit variable here. Let's see. Oh, it kind of worked, but I would like to see if these are moving actually. Okay. Net object has no attribute inputs. Well, did I keep something wrote as net? Net. I said model equals net. Model.parameters. Torch device CUDA time epoch inputs label inputs to device labels to device model.inputs torch max output labels. What is wrong with you? Okay, hold on. Module.py model.inputs. Net has no attribute inputs. Oh, this is about my net. These net has no parameters? There's no inputs? What? Okay. No worries. I have a net here that should be working. If I copy that model, will it work? Just curious. Let's call these model. And it's pretty much the same model, like nothing is different. I think I did copy that from the same place. They're a little bit different, but no, not much. What? Bro, what? What is going on here? Okay. Now from model import model. Model equals model. WQ, do a WQ as well. Run try. Bro, this is a weird error. This is not what my error was. I can afford. And then flat. finish